Okay, so this is chapter 4 concerning the first part of genetics, and I'm going to start off chapter 4 talking about alleles. Previous to this, the only thing that I've covered is simply the fact that half of your genetic information has come from your mom and half of your genetic information has come from your dad. But you have this concept of alleles, and every single person, no matter what the gene is, has two alleles. And the alleles, you got one from your mom and one from your dad, and that together combines together to see how it is you're going to look or how it is that you're going to act. So here's some vocabulary words that are really important: genotype, phenotype, wild type, and mutant phenotype, and homozygous and heterozygous. Let me show you how they kind of all fit together. So if you look at an allele, if you look at a gene, let's start off with a gene. I'm going to do this. So, gene. So a gene is an instruction to do something. So I'm going to look at the gene for a rabbit's fur color. Right, so the gene is the actual category. And then you're going to wind up having, what are your alleles for it? Well, an allele is a different type of gene. So my alleles could be, so I'm going to say allele. My alleles could be black. My alleles could be white, could be gray, could be brown, could be tan, and so on and so forth. There's a bunch of them. You have to represent your two alleles that you always have, and I always show when I'm initially doing this, there's my two alleles for bunny number 1. So I'm going to do 3 different bunnies. Here's bunny number 1, bunny number 2, bunny number 3. So you always have to have two alleles that determine the bunny's fur color as we're doing it. If you remember from biology, you always pick the dominant color. So you have dominant traits and you have recessive traits. The dominant traits are stronger, and if you have even one of the dominant traits, you're always going to show that particular dominant trait. The only way you're going to show a recessive trait is if neither of your alleles are dominant, and you only have the recessive alleles. For fur color, black is the dominant allele, and white is the recessive allele. And if you also remember, you choose the first letter of your dominant allele in order to designate your alleles. So I'm going to say that, give myself a little bit more room here, I'm going to say, now I'm dealing with black and white, I'm going to say that big B is my black allele and little b is my white allele. So, you can have bunny number 1 is going to be black, and both alleles are going to be black. So if you look, this will be a black bunny. You can also have a black bunny if one of the alleles is black and the other one is white, because remember this strong one right here, this dominant one, is going to overpower the recessive trait. So you're only going to see the dominant alleles. So this will also be a black bunny. Bunny number 3, on the other hand, is white. It's just like Lola. Lola's got the recessive trait. The only way that she's white is because she has no black present. So both of her alleles are white. So this would be a white bunny. I actually got rid of the eraser. Okay. All of what I just listed, these right here, so the colors that the bunnies actually are, this is the phenotype. Those are the physical traits. What does the bunnies actually look like? What color are the bunnies? Well, 2 of them are black and 1 of them are white. 1 of them is white. That's the phenotype. This right here, this column right here, this is the genotype. Genotype is what's in your genes, so what are the alleles actually are. Phenotype is what they physically show. Genotype are the actual alleles. Last thing I wanted to do before I go on is the concept of homozygous and heterozygous. Homo always refers to same, and hetero always refers to different. So because these two alleles, this one is dominant and this one is dominant, both are dominant, so both are the same. So this is considered homozygous dominant, because both are dominant. Likewise, if you look at the bottom, the last bunny, both of them are recessive. This bunny number 3 has 2 white genes. They're both the same. So this is also homozygous. But it's homozygous recessive. Sorry guys, this is really, really hard to write on. The guy in the middle, this one right here, has 1 dominant and 1 recessive. So those are different alleles. So this is heterozygous. The last thing I wanted to cover was concerning how to do a Punnett square. How to do a Punnett square. So Punnett square is a way that you represent the alleles that you're going to be working with and the children that are going to potentially result from whatever 2 parents that you want to deal with. So getting back to our bunny, I'm going to take the one bunny, bunny number 3, that was little b, so this was one of my white bunnies, and I'm going to take another bunny. I'm going to take bunny number 2. No, I'll take bunny number 1. And bunny number 1 was homozygous dominant, so that bunny, that bunny has 2 alleles. Most people remember from Punnett squares, when you draw a Punnett square, looks like that. Each box right here, this is 25%, this is 25%, this is 25%, this is 25%. So altogether they make 100%. So if you only had one box that you're addressing, the offspring would be 25% of the offspring. If you had 2 boxes of whatever trait it is you're looking at, those would be 50% of the offspring. 3 boxes would be 75, and 4 boxes would be 100%. So when I'm doing Punnett squares, I always have the mother's alleles on the top. So mom goes on the top, and dad goes on the side. And Lola in our class is white, so she's a female, so I'm going to put one of her alleles over this box and one of her alleles over that box. Dad, on the other hand, is homozygous, so I'm going to give him one of his alleles here, one of his alleles here. The way that you do it is wherever the allele is, this guy right here, that's right here, he's sitting in this row, so you bring him here and you bring him here. This guy right here is sitting in this row, so you bring this B over and you bring it over there as well. The ones up top, they're sitting in this column, this one's sitting in this column, so you bring them straight down. Then if you look at the offspring, the question is, what do you wind up having? Well, every single offspring here, this one, this one, this one, and this one, has one of the dominant alleles, which means that they will be black. They only need one to show it because it's the stronger trait. So it is, they all have one of the dominant alleles. So 100% of the offspring will be black. That's my phenotype. 100% is black. My genotype, if I asked you what genotype is, you've got one big B and one little b. That's the genotype. So 100% would be big B, little b. Let's do one more and then I'm going to stop. Let's do humans. We're going to do human eyes, and we're going to give them something really crazy. We're going to say purple eyes and red eyes. And I'm going to say that red eyes is dominant. So this is my red allele. And lowercase r is my purple allele. If I said that mom had purple eyes, you would fill in little r, because if mom carried a big R, she would have red eyes. And we don't want her to have red eyes, we want her to have purple eyes. We're going to say that dad is heterozygous for red eyes. So he's got one of the red and one of the purple, but he will have red eyes when you look at him. Then when you fill this in, what do you wind up with? Well, these offspring right here have one of those dominant traits. So they will both be red. So 50% will be red, or 2 out of 4 boxes, which is 50%. These guys down here, they do not have a dominant allele. They don't have the red, so the only thing that you have left to show is the purple. So 50% will be purple.